Hi, this is Neelima, Aptitude trainer from DURGASOFT. Today let's discuss a very important topic and also which is completely related to the basic mathematics, that is which is completely related to the figures, 2D figures, 3D figures. The topic is mensurations. Everybody know mensuration is completely deals with the triangles, rectangles, all the 2D figures and 3D figures. And we have to remember all the formulae for 2D figures, 3D figures and everything. So let's see some of the important formulas along with the diagrams so that we will be having an idea when we are going into the main questions, we will having an idea how to solve that kind of questions. So let's see some important diagrams along with the formulae. So let's see some of the mensuration diagrams. In mensuration we are getting 2D figures and 3D figures. So let's see the figures which are to the extreme left are called as 2D figures. Here if we can see, we are having different type of 2D figures: triangle, square, rectangle and circle and rhombus and everything. And if we go for a 3D figures, we have 3 type of 3D figures: cylinder and everything. So in 2D figure we will be finding out what will be the perimeter of that 2D figure and what will be the area of that 2D figure. And in 3D figure we have to remember we are finding lateral surface area of that particular figure, total surface area and the volume. So when we are dealing with the 2D figures, we are just finding out what is the perimeter of a 2D figure and its area. And coming to 3D figure, we are finding lateral surface area, total surface area and the volume. So now let's see individually what will be the figures and how we can go with the figures. Let's start with the triangle. In triangle, let's see what are the common properties in triangle, right? So if we can see here, there is a triangle with the different angles and the different sides. Sum of the all angles is given, sum of the all angles is 180 degrees, we all know, and that means capital A, B, C, we are treating them as angles. So A plus B plus C is giving us 180 degrees because sum of all angles is 180 degrees. So all the angles, if we sum up, we are getting 180 degrees. Next, length of any side is greater than difference and less than sum of other two sides. Length of any side is greater than difference and less than sum of other two sides. That we can take it as mod A minus B is less than C is less than A plus B, where small a, b, c we are taking it as sides, we are considering them as sides. So we will be getting, we can consider it as modulus A minus B is less than C is less than A plus B. And we can we can take this modulus, we started with A minus B modulus, we can even take C minus A modulus, which is less than B less than C plus A. If it is mod B minus C, it is less than A less than B plus C. Next, the length of a smallest side is always opposite to the smallest angle. This is the important point when we are trying to find the angles or whenever we are trying to find the sides of any two sides of a triangle. We have to consider this point, the length of sides, smallest side is always opposite to the smallest angle, and the length of longest side is always opposite to the biggest angle. If you can see here, if you can consider this diagram, you will be getting the conclusion for these 2 points. Length of smallest side is always opposite to the smallest angle, whereas length of largest side is always opposite to the biggest angle. Let's see some different triangles. Let's start with the first equilateral triangle. If you can see the figure, equilateral triangle, all the angles will be 60 degrees and all the sides are equal. In equilateral triangle, we are getting all the sides which are 60 degrees and all the sides are equal. And if we discuss about isosceles triangle, in this isosceles triangle, only 2 sides are equal and only 2 angles are equal. That means in this isosceles triangle, 2 sides are equal and 2 angles are equal, right? And if we see the next triangle, scalene triangle, in scalene triangle we have all the angles are different and all the sides are different. If you can observe in the figure, whatever the angles we can see here, if we observe in this figure, whatever the first angle, or you can consider 1, 2, 3 as the angles, one angle is not equal to second angle is not equal to third angle, and in the same way first side is not equal to second side and second side is not same as like third side. So in scalene triangle we have all the sides different and also all angles are different. And if we discuss about acute angle triangle, where if you observe in the figure, here in the figure the angles are less than 90 degrees. In acute angle, all the angles are in such a way that they are less than 90 degrees, right? If you can observe in this figure, you will get an idea then how an acute angle can be, and which is less than 90 degrees. And if you talk about right angle triangle, it is very familiar triangle. Even when you are going for a other topic which is directions, this right angle triangle will play an important role in directions problem solving. Let's discuss about this right angle triangle. Right angle triangle, in the name itself it is giving us that right angle triangle, in the sense in all the angles only one angle will be correct, one angle will be exactly 90 degrees, right? And if you can see, sides are different in this right angle triangle, right? So one of the side we are considering it as a side 1 and the other side we are considering it as side 2, and the opposite line or opposite side which is opposite to the angle 90 degrees, we are considering it as largest side, or else you can consider it as side 3, or you can consider it as hypotenuse. If you are going into the directions, we are just considering them as side 1, side 2 and side 3, right? So what are the important points in this right angle triangle is, right angle triangle has one side as one angle as 90 degrees and it has 3 sides which are different. Side 1, so we are considering it as side 1, side 2, side 3, or you can consider the side which is opposite to angle 90 degrees as hypotenuse. So if we discuss about the points, right angle triangle is also this triangle is also called as a Pythagoras theorem, right? So Pythagoras theorem formally gives us like hypotenuse side square. That means we have the other name for this as hypotenuse square, in the sense side 3 square is equal to side 2 square plus side 1 square. You can take in any ways. Hypotenuse square is equal to side 1 square plus side 2 square, right? This is the Pythagoras theorem. So this theorem is most useful when we are doing the direction problems. Depending on the concept whatever we have here in right angle triangle, we are using the same concept in directions, and we are just using side 1, side 2 and side 3. Here benefit is like, if we know side 1, side 2, or if we know any two sides, if we know any two sides in this triangle, we can find out the other side by using this formula: hypotenuse square is equal to side 1 square plus side 2 square. So it is important that we have to know two sides. With that two sides, we can go for the other two side. We can find out the other two side by using this formula. This formula we generally call it as Pythagoras theorem, right? Let's go to the next figure. Next triangle, obtuse angle triangle. If you observe in this diagram, obtuse angle triangle, which is greater than, one angle is greater than 90 degrees. If you can see here in this figure, one angle is greater than 90 degrees, right? So if the angle is less than, if the angle is correct 90 degrees, that is proper 90 degrees, we are treating it as right angle triangle. If it is greater than 90 degrees, we are treating it as obtuse angle. And if we go for the next triangle, which is trisexa right angle triangle. If we observe in the figure, this is the actual figure for trisexa right angle triangle. If we observe in this figure, all the angles are given in this form. One of the angle is 30 degrees, and one of the angle is 90 degrees, and the other angle is 60 degrees, right? So if we can see in this figure, angles are given clearly. One angle is 90 degrees, other angle is 60 degrees, and other angle is 30 degrees. So for this, angles ratio will be 90:60:30:60:90. So that will give us a proper ratio of 1:2:3. So sides ratio, even we can remember sides ratio for this. Sides ratio will be around 1:3:2. Let's talk about the next isosceles right angle triangle. If we see here isosceles right angle triangle, where as it is in the name itself, it is given as right angle triangle. One of the angle is exactly 90 degrees, and the other two angles are 45 degrees one angle and 45 degrees other angle. And the sides we can consider as side, we have side as AB side is A, and side for AC will be A, and side for we can take it as side for BC will be root 2A. So here also we can just find out angles ratio. Angles ratio will be 45 degrees plus is to 45 degrees is to 90 degrees. Even that gives us a ratio of 1:1:2. and sides ratio will be 1:1:√2, as A is common in all the sides, so the side ratio will be 1:1:√2. Let's go to the next triangle, which is let's go for the area of a triangle. Area of a triangle, if you can observe here, one of the triangle has been given in this figure, and the sides are given as side A, side B, side one of the side is A, other side is B, and the other side is C. And if we can take this line as height, right? So if we already know that area of a triangle is half into base into height. So if we can take by sides, this can be also written as under root s into s minus a into s minus b into s minus c, right, where s can be written as s is equal to a plus b plus c divided by 2, right. So this is the area of a triangle, where you have area of a triangle is given as half into base into height, and it can also be written as under root s into s minus a, s minus b, s minus c, where s we can take it as s is equal to a plus b plus c root 2 divided by 2. Let's go for the area of an equilateral triangle. If we see here, there is one equilateral triangle here, and where in equilateral triangle all the angles are 60 degrees and all the sides are same. All the side we are considering it as A, so all the sides are equal and the angles are equal. So sides we are considering it as all the sides we are considering it as A, because all the sides are common here. So sides we are taking it as A, all the sides are common, so we are considering it as A. So we have 3 sides as 3 A's, and angles are same. In this equilateral triangle, angles are same. Angle is 60 degrees, so we are considering we have all the angles as 60 degrees, and if this line will be height, right. So if we go for an area of an equilateral triangle, area of an equilateral triangle is root 3 a square by 4. Area of an equilateral triangle is root 3 a square by 4, and where height, or we can call it as altitude, is equal to root 3 a by 2. So these are the important points we have to remember regarding this area of an equilateral triangle, where area of an equilateral triangle is root 3 a square by 4, and height or altitude is given as root 3 a by 2. Let's go for the next figure. If we can see the next figure, let's discuss about square here. If you can see in square, all the sides are same, so we are considering side as A. Here if we see, all the sides are same and all the angles also will be same, but we are only talking about the squares, and all the sides are same, right. So now the perimeter will be addition of all the sides, that is, it's a combination of all the sides, sum of all the sides, we can take it as perimeter. So as we have 4 sides here, perimeter is equal to 4a, and coming to the diameter, d square is equal to a square plus a square. Diameter we can consider it, diameter will be d square is equal to a square plus a square, which can also be written as d is equal to under root a square plus a square, and that will be d is equal to root 2 under root 2 a square, right? And it can also be written as root 2a, as square and root of this diameter will get cancelled. So at last we got a diameter as root 2a and the perimeter as 4a. Just remember, whenever it is about a square, perimeter is 4a and diameter is root 2a, and the area will be a square. Area will be a square. So in square, just remember diameter, perimeter and the area, right? Let's talk about the rectangle. If we see here in rectangle, perimeter in figure, rectangle figure, if you can see, here is the length and this will be the breadth and this is the diagonal, where in rectangle only two sides, opposite two sides are equal and the other opposite two sides are equal. That means two parallel sides are equal in rectangle, and you can see the diagonal here, and the angles also will remain same here. So if we talk about the rectangle, perimeter is equal to 2 into L plus B, that is 2 into length into breadth, 2 into length plus breadth, and diameter will be, diagonal will be length square plus breadth square, right? L square plus B square. That can also be written as d is equal to under root L square plus B square. So this is about rectangle, where we have to know about the perimeter, that is 2 into L plus B, and diagonal d is equal to under root L square plus B square. This is all about rectangle. And if we talk about the area of a rectangle, length into breadth will give us the area of a rectangle. So next figure, rhombus. When you are going for the rhombus figure, you can just remember, you can just imagine the figure of the actual shape of kite. Rhombus is, in other words, we can consider it as kite. So here in rhombus, all the sides are equal, right? All the sides, if you can see in this figure, all the sides are equal, and there are two diameters. One is two diagonals, which are d1 and d2. We have two diagonals, d1 and d2. So area will be, area of a rhombus is d1 into d2 divided by 2. Area of a rhombus is d1 into d2 divided by 2. All the sides are equal in rhombus, right? And next, parallelogram. Parallelogram, you can see the figure here. If you observe A and B, that means opposite sides are equal, right? And you can consider this as height, right? And this as base. So area of a parallelogram will be base into height. You can see this will be the base and the red line will be the height, where the sides are A. And if we talk about the trapezium, you can see the figure here. In trapezium, the lengths of if we consider the down length as B and upper side as A, and this will be the height in trapezium, right? So for trapezium, we have area as h by 2 into a plus b, h by 2 into a plus b. And let's talk about quadrilateral. if we talk about the quadrilateral may be in any kind of figure. Whatever the figures, if we can see here, we have different type of figures here. So among these different type of figures, any figure can be a quadrilateral triangle. So it doesn't have a particular only conformed quadrilateral. So all these figures which we can see here are called as quadrilaterals, right? So for quadrilateral we have a formula: angle A plus angle B plus angle C plus angle D is equal to 360 degrees. So total all the 4 angles, if we sum up, we will be getting an angle of 360 degrees, right? So let's discuss the area of a quadrilateral. If we consider one of the diagram, one of the figure, so this as, we'll take this as diagonal D, and this has height h1 and this as height h2, right? So here in this quadrilateral figure we have a red line diagonal and we have 2 lines h1 and h2, right? If we come to the area of a quadrilateral will be d by 2 into h1 plus h2, right? Area of a quadrilateral is d by 2, that is diagonal by 2 into h1 plus h2, height 1 plus height 2, right? And let's go for the next figure. Circle. You can see in this figure, circle, there is a 2 points. We have taken just 2 points in circle, A and B, and which is we have one center point O and D as a diagonal. If we can see here, center as O, and we have a red line which is radius. So the radius which is taking a half distance from center, and diagonal is taken as D, which is 2r, right? Diagonal is combination of 2 radius, that is half radius, complete diagonal will be 2r. And if we talk about the perimeter value will be 2 pi r. And if we go for the area will be pi r square. So in circle we have to remember center as if you consider in circle 2 points, consider 2 points on a circle, point A and point B. From that take O as a center origin, and from O to the point where it is touching the circle, we treat that as radius, and the diagonal is this diagonal will be D, which is equal to 2r, right? And the perimeter of a circle is 2 pi r, and the radius is equal to pi r square, where pi is 22 by 7, where pi value is 22 by 7. Let's go for the sector. If we see here, this is the actual figure of sector. If you can see the pink and red colored figure, here whatever the color is in red color, we treat that as sector, right? And for this sector we have an angle theta degrees and the radius r, right? So if you see the actual figure of sector here on the other side, on the right hand side, all the shaded color we are treating it as sector, and all the green colored shaded figure is sector, and to that sector we have an angle of theta and radius r. So we will have 2 radius r, and the length will be L. and the other radius r, right? If we talk about the perimeter of a sector, it is r plus L is equal to 2r plus L. R plus L, if you see on this green color shaded figure, we have a radius of r there, r here. So r plus L, L is length of a sector, we can see here in the figure. So it is giving perimeter of a sector will be 2r plus L. And coming to the area it is theta divided by 360 pi r square, right? Area of a sector is equal to theta divided by 360 pi r square. So two important points: perimeter of a sector 2r plus L and area of a sector theta by 360 pi r square. And if we talk about the length is equal to r plus theta, right? So these are the important points about sector. Perimeter is equal to 2r plus L and the area is theta by 360 into pi r square, where pi we know 22 by 7, and length is equal to r into theta. Let's talk about the cube. If we see cube, all the sides are same, so we are taking sides or individual side as A. If you can see the figure here, on the other side all the sides are same, so sides are taken as A. And if you can go for the diagonal, this D will be the diagonal, and the diagonal is equal to under root 3a, right? Diagonal is equal to root 3a, and total surface area is equal to 4a square. Total surface area, in the sense we are just taking the total surface of a cube. Total surface area we are getting it as 4a square, and lateral surface area for this cube will be 6a square. So in cube we have diagonal, which is D, is equal to root 3a, and lateral surface area 4r square, and total surface area as 6a square. Just remember these points in cube, as all the sides are same, and all we can see the diagonal here. So diagonal we are taking it as root 3a, lateral surface area 4a square, total surface area 6a square. So we have a volume which is equal to a power a cube. We have a volume a cube. So volume of a cube is equal to a cube.